everyone. In our previous discussion, we were able to discuss about different types of sets and its examples, such as a set of natural numbers consists of 1, 2, 3, 4, 5, 6, 7, 8, and so on, and set of whole numbers. These are a set of natural numbers including 0, set of integers. As you can see, these are the elements in the set of integers. The negative natural numbers, including 0, and also the positive natural numbers, and the set of rational numbers. So these set of integers, set of whole numbers, and set of natural numbers are considered as set of rational numbers because um, we think that there is an over 1 for every number here because 2 over 1 is equal to 2 or 3 over 1 is equal to 3. Now, here's another type of set of number, which is set of irrational numbers. So set of irrational numbers, we have square root of 2, square root of 3, and so on. Now, actually, these are these set of numbers are just part of the set of real numbers. Now, we will not be dealing with this again, the type of sets of numbers and its examples, but I show you this because our topic for today is about subsets. Okay, now what is a subset? Definition: the set A is a subset of B if and only if every element of A is also an element of B. Then we use this notation, to indicate that A is a subset of the set B. So it's clearly say here that A is a subset of B if and only if every element, meaning all elements in the set A, belong to set B, for us to say that A is a subset of B. And this is the notation for subset. Okay, now we see that A is a subset of B if and only if the quantification for every x such that x in A implies that x in B is true. So if this quantification is true, then we can say that A is a subset of B. As you can see here in this illustration, we can say that A is a subset of B because A is just a part of the set B. Then we say that A is a subset of B. However, we use this notation, and later you will know why we use this notation instead of this notation with a horizontal line. Okay? Now, showing that A is a subset of B, to show that A is a subset of B, you have to show that if X belongs to A, then X also belongs to B. Because for a set to be a subset of B, then all the elements in that set must belong to the bigger set. Okay? Now, showing that A is not a subset of B, to show that A is not a subset of B, we must find a single X, single element in A, such that that element X is not in B. Okay? A is not a subset of B, provided that we can find an element in A which is not in B. Okay, now when we wish to emphasize that a set A is a subset of a set B, but that A is not equal to B, we write this notation and say that A is a proper subset of B. So earlier in our illustration, we use this notation because we clearly see that A is smaller compared to B. That's why we use this notation, and we say this as proper subset. This is a proper subset if we know that A is not equal to B, although all elements in A belong to the elements in B, or the set B. Now, this means that set B, okay, has members that do not belong to set A. Okay, so meaning there exists an element X of B that is not an element of A. That is, A is a proper subset of B if and only if this quantification is true. That means that for every x such that x in the set A implies that x in B, okay? Because it's a subset. However, there exists x in B such that x not in A. Okay? So, meaning to say, if we can find an element in the bigger set which is not in A, then we can say that A is a proper subset of B. Okay? Now, if all of the members of set A are members of set B, and that there are no members of set B that are not members in set A, meaning to say A is equal to B, then we use this notation. We say that A is an improper subset of B. So we have always remember that if A is equal to B, then we use this notation. But again, this is the notation for the general notation of a subset. But if we clearly know that A is equal to B or A is not equal to B, then we use the notation proper subset or improper subset. To give you a detailed explanation, we have examples. So for example, we are given the universal set W, which is the set of whole numbers, is given by the set of 0, 1, 2, 3, and so on, be our universal set. Then we also have set A, which is a set of 1, 2, and 3, and set B, which is also a set of 1, 2, and 3, meaning set A is equal to set B. Then set C is equal to the set of 5, 6, and 7, and D is equal to the set of 0, 1, 2, 3, 4, and 5. Okay? Now, to give you a clear visualization of this example, we use Venn diagram. That is, we draw first a rectangle that represents the universal set, and we have universal set W. Let's say the elements are 0, 1, 2, 3, 4, 5, 6, 7, and so on. Then using Venn diagrams to illustrate the set A, B, C, and D, we have this one. Okay, so set A, the elements of set A is equal to set B are 1, 2, and 3. Set C, 5, 6, and 7. Set D, 0, 1, 2, 3, 4, and 5. And we clearly see that D and C have common element, which is 5. So it has an intersection, or they have an intersection. Then the element of the intersection is 5. Then we have this conclusion that A is a proper subset of D. Okay, why proper subset? Because all elements in A or in B, 1, 2, 3 are also in D. However, there are elements in D which are not in A or B. That's why we use this notation, proper subset of D. However, in C, if we are going to go back to C, we clearly see that the elements are 5, 6, and 7. However, 6 and 7 are not in the set D. So we found elements that are not in D. Therefore, we can say that C is not a proper subset of D. Okay? Now, in this example, it is given by these two sets. That set A consists of 1, 2, 3, and also set B. This means that A is equal to B. Therefore, we can say that A is an improper subset of B. Okay? Now, another set of examples. Some of these are real-life applications. Some also are not. For example, we have set of all odd positive integers less than 10 is a subset of the set of all positive integers less than 10. That is, A is equal to 1, 3, 5, 7, 9 because this is a set of all odd positive integers less than 10, and B is the set of the all positive integers, positive. So positive integers, they are even or odd, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we say that A is a proper subset of B because all elements in A are in B, but not all elements in B are not in A. So we use the notation, the proper subset notation. Then the set of rational numbers is a subset of the set of real numbers. We have shown this earlier, okay, when we show the illustration of the Venn diagrams of the set of numbers. So we clearly see that the set of rational numbers is a proper subset of the set of real numbers. Another example, the set of all computer science majors at, at your school, for example, is a subset of the set of all students at your school. Okay? And number 4, the last one, the set of all people in Visayas is a subset of the set of all people in the Philippines. Okay? Because we know that the size of the population in Visayas is smaller compared to the whole population in the Philippines. That's why we can say that uh, the the set of all people in Visayas is just a subset of the set of all people in the Philippines. Okay, so these are examples of subsets, and hope you like this video and hope you learn this video, and don't forget to share the learning that you've got from this video. Thank you so much and God bless.